Introducing Pythagoras' theorem. Pythagoras' theorem states that in the right-angled triangle shown below, we can see it's right-angled here. C is the longest side, known as the hypotenuse, and A and B are shorter sides. That the length of A squared plus the length of B squared is equal to the length of C squared. As mentioned, the longest side is called the hypotenuse. Pythagoras' theorem only applies in right-angled triangles. So if we find a triangle in which a squared plus b squared is c squared, where c is the longest side, the triangle is right-angled with the right angle opposite the side c. So what we're saying here is that Pythagoras' theorem works both ways. If we know the triangle is right-angled, then this applies. If this applies, we know the triangle is right-angled. It is thought that this was spotted from tiling patterns. Here we can see some information about Pythagoras. Calculate the value of x in the triangles below. So we can do this using Pythagoras' theorem. We can see that x is the hypotenuse, the longest side. So x squared must be equal to the other sides squared and added. So that means that x squared is going to be 9 plus 16. X squared then is equal to 25, and x must then be the positive square root of 25, which is 5, and the units here are centimetres. Once again here we're finding the hypotenuse. So x squared is equal to 6 squared plus 6 squared. Now I'm just going to calculate that. So I've got 6 squared plus 6 squared, and that gives me, I'll just bring the calculator into view here. I'm not using the same calculator that you use. And so that gives me 72, and then x would be the square root of 72. And so I just need to square root that. So square root of 72. And that gives me 8.485 and so on. I'm going to give that as 8.49. And the units are millimetres. And I'm giving that correct to 2 decimal places. Calculate the value of x in the triangles below, and we can see here that x is now a shorter side. So, always start with the hypotenuse on its own. So x squared plus 15 squared must be equal to 17 squared. So the hypotenuse is on its own. Subtract 15 squared from each side, and then x squared is 17 squared minus 15 squared. So I'm just going to calculate that. Once again, I'm going to bring my calculator in here. So I've got 17 squared, take away 15 squared. That gives me 64. And then x would be the square root of 64, which we know is 8, and the units here are centimetres. So that one worked out exactly with this being 8, 15, 17. When you have 3 whole numbers that work in a right-angled triangle, that's known as a Pythagorean triple. X here also is a shorter side. The other shorter side is the 6, and then the hypotenuse on its own. So we've got x squared is going to be 9 squared minus 6 squared. So we can calculate that. So we've got 9 squared, take away 6 squared. That gives me 45. I don't know the square root of 45 offhand, so I'm going to have to calculate that. So we've got the square root of 45, and I'm going to give that a 6.71 once again, using 2 decimal places. So 6.71 millimeters to dp. Finally, we want to check to see if the following triangles are right-angled. The longest side here is 13. So 13 squared is equal to 169. Now let's look at the shorter side squared and added. So we've got 5 squared plus 12 squared. That's going to be equal to 25 plus 144, which gives us 169. So we have a situation where a squared plus b squared equals c squared, and that only happens if the triangle is right-angled. Now let's check this one. The longest one is 7. 7 squared is 49. 4 squared plus 6 squared is 16 add 36, which is 52. So these are not equal. So a squared plus b squared is not equal to c squared, and that means that the triangle is not right-angled.